Hello everyone, it's April the 5th. We have not much time. 23 minutes, not 23, 32 minutes left. Alright, let's go for it. Container with most water. That was an old problem, very old. Oh, remember this one. I remember this one. I solved this one many times. It's a very tough problem for me. I struggle a lot. Let's see if we can get it this time. If I remember correctly, I think there is a two-pointer solution for this. All right, let's just reread this. Give an integer of heights. Find two lines that together with the x-axis form a container such that container contains the most water. Yes, I remember this one. If I remember correctly, is this the... No, I don't think this... No, this is not the monotonic array. This is the two-pointer solution. We have a pointer on the left, pointer on the right. And I think is to find... Hold on. So, if a pointer on the left and pointer on the right, if the leftmost is smaller than the right, and then the water is determined by the left, and we walk. It's determined by the left, so we keep walking, and then every time we walk, we can increase until we hit a time when the left is larger than the right. And if the left is larger than the right, then the volume is determined by the right. And then we walk right forward, right? And then it'll be something small. Then, we just keep walking forward, and every time when we hit whatever, and then it's just going to be the right times, okay? And then the right move forward, and then it's going to be determined by the right until we hit. Okay, I think that is a solution. This is an old problem. It's good, from time to time you solve this old problem, kind of just see if you still got it. All right, let's see. So we have low and high, right? So 2 pointers, 0 and length height. Let's say -1, okay? And then we can say while low is smaller than high and rest. We want a maximum, right? So rest equals 0, while low equals high. If height low is smaller or equal to, it's fine, then height high, right? Then rest equals to maximum, rest height low times high minus low. Do we have to -1? 0, 1, 2, 3, 4, 5, 6, 7, 8, right? 8. And 0, and so we have a difference of 1, 2, 3, 4, 5, 6, 7. Yeah, so I don't think this should be good enough. Yeah. So rest equals this, and low plus equal 1. Else, copy this, and then this will be high, right? Because high is smaller, so high. And this will be high minus equal 1. And then we keep going until we merge, and then we return rest. All right. Let's see. We have this 49, 1, 1, 1. Height, max area height. Right? Seems to be right. we can, it's throwing another one. Just for fun. Like like that. Doesn't matter. I think that is the way to go. Oh, they probably changed. 900. All right, so that was a year ago. So this is LeetCode 11. Still remember, I still remember how this problem is solved. 2 pointers from both ends, right? From both ends. Whichever points to the lower height determines the amount of water that can be held. Keep moving the pointers towards the center, right? When when the height being pointed is smaller than the other, and I'll keep moving to the center, and then that's it. It's ON. This one is 931.54. That one was actually I should check. I think the test case must be different now, because you see the average is around 800, 900. 56 back then, 56 test cases. Look at this. Maximum rest and this times, times the minimum. That's good. So, well, it's the same. It's the same. But I can do this, right? And then gonna be the min of this and height high, right? And then if this, so we just save like 2 lines. Yeah, save 2 lines. So 56 test cases, 60 test cases. All right, so we're done with this. Back to this. So we didn't finish it yesterday because we kind of ran out of time. But today, let's keep going. So what we left from yesterday was I start with 2 strings to complete, right? And then the matching is the entire thing. And then we start to shift, right? We start to shift, and then we start to have a no match until we find the first time we match, right? The first time we match. So once we find the first time we match, we can match, certain number of times, right? Certain number of times, and what we know is, once you match, then we can jump forward, right? That's the idea of jumping forward, because we have, like, initial is a full match, and we have to jump forward, let's say X positions, to have the second match. Therefore, whenever we have a full match, we won't have another match until jump forward that number of times. But now there's a problem, right? There's a problem, because initially I have a full match. And then we jump forward, let's say X times. But now I might not have a full match now. Now I have maybe like a partial match, right? A partial prefix match. So when I match the prefix, and then we hit the first one as not matching, well, of course, we record the score. And then what? I think, and then we need to depend on the the length of the current match, right? If the current match length is longer than the jump we already have, than the another match we had already, then in that case we can say that that's the same situation as a full match, right? And then we have to at least jump forward that number of times, right? Because basically just for a full match we have to jump that number of times, and if we don't jump that number of times, it's not gonna work, right? It's not gonna work because you move forward and then you move forward, you start trying to match again, and it just doesn't match. Yeah, because it's the wait, hold on. What do you mean by move forward? It's the index move forward, right? That just doesn't match. I have to move at least that number of times. So if the matching length is larger than the initial, then we have to move the initial number of times, and then we check again, right? So now, what if the matching length is smaller? So we have not match, boom, we have match. Let's say we have only one match, all right? We have one match, so it's smaller than the the previous one. Then how much we should jump forward? So if we match, like, let's say it's not a full match, like a match a little bit, then what do we know is because it's smaller than this, we have to jump forward that number of times, all right? That the matching number, however number we match, we have to jump forward that number of times. Why? Because those are the match, so they will have to jump forward that number of times. Okay, so we do jump forward, but what if we have just match once? Okay, so now we jump forward once, basically just jump forward that number of times. So we check this one again and say it's matching again, and jump forward and matching again and jump forward. And what if now I have multiple matches? Okay, I have multiple matches, but it will not be as much. So the initial one will be okay. So how are you gonna handle, let's say A? Okay. So we have a full match, we know, and then we jump forward. No, not jump forward. So like this, right? And then initially the full match, and then we go to this position, and in this position we compare. Oh, we match, and we match. So when we move forward, we do another full match. So we match at the beginning, and then we move forward, and we have match. We match again. What do we do with that? We match again. Well, if that happens, we match again. Enjoy. So when we have the full match, right, and then we move forward and we match certain number again. Well, if we match a certain number again, what does that mean? That means if we go forward, we'll at least match that much, right? Hold on. So initial is match, right? And then we move forward. Initial is match, and then we start from this. We start comparing. So match. So we'll, or like not match. So we'll have the second time, right? The second time we match. Okay, the second time we match a certain amount, and we'll record the score. And based on how much is in the front, then we know how much we should skip. But now we have nothing in the front, right? Because this one's matching, right? So have these much match, right? So we know initially is match, and then we shifted, we still have like a certain number of match. What does that tell us? That tells us this is equal to this, right? So if I have these elements and I have like, I don't know, certain number of elements, and we say like this and this match, this and this match, this match, this match, this match, okay? So I have these match, but at the same time, this is equal to this, okay? So this is equal to this and this, so these two are equal. So this is equal to this, these two are equal. So that will only happen if it's consecutive. So if that happens, it must be consecutive. So consecutive holds a different meaning, right? Holds a different meaning. So what can we do? Well, what we can do is going in the front, right? And if we have consecutives at the front, count how many consecutives we have. Because if the front is not consecutive, then we'll have mismatch, right? It's not possible to shift and still match. If we want to shift and a match, it has to be consecutive. And if it's consecutive, we know the total number that all these consecutives can do, and we simply just we can shift away from the consecutives. Okay, that's a thought. So if we have a consecutives at the front, right? So we count how many consecutives they are, and then we know how many. It's just the number of consecutives plus -1 plus -1 all the way plus to 1. So we know that. Okay, we know that. So once we do, we just shift all the way to the first one that's not consecutive, right? And then from there, we're going to do the comparison. We compare until, oh, hold on. Let me think again. So we have a consecutive with something, and now it's consecutive with something. When we shift one, so we have one less consecutives, right? Yeah, for one less consecutives, that's all it can be done because it won't be able to extend. That's not a prefix. So we exhaust all of them, and then we first no good until we finding the same again, and then we try to see if we have consecutives. Okay, so we compare, and it's equal, and then we just keep extend, right? We'll keep extend until something that we can't, and then we grab this is the score, right? And then for the remaining is just the consecutives. Yeah, we'll just do the consecutives, and the rest will not work. Is that right? The rest does not work. Hold on. me think again. If we have consecutives, right, and then we have consecutives matching, like until certain spot doesn't match, and once it's done, we shift 1, then we have the consecutives. So we can handle all the consecutives. We can think of the consecutive as one element, right? And then once the consecutives is done, then I start to check if it's equal until we find the next one. Complicated. Let me think again. If we have a bunch of matching, right? So we match, and then we shift, right? And then it doesn't match, right? And then we check the next one, doesn't match. Next one doesn't match. Until we find someone that does match, right? Then what we do know, so we match until we finish the matching. So we have that, and then then we just basically shift that much. So we start from this and then check again, right? So if we have consecutives, it'll be the same, right? We just match, everything match, and then count the number of consecutives, and then we handle the consecutives, right? We handle the consecutive. We do this, and we handle the consecutives. Then what? Then we jump to here, and we compare until we find the next match. Then we have the distance, right? So that is the distance, right? So like after we match, as we know that the initial is a full match. So after the full match, the next match will happen after going through a certain distance, right? A certain distance. So no matter, like if it's consecutive, we're just matching the consecutives, and then after matching the consecutives, okay. So doesn't match. So we match the consecutives, then we can compute, and now we have something that doesn't match. Then we hold on. And keep going until something we start matching. So we match, right? And then boom, we have the thing that doesn't match. And then we have a thing that doesn't match. And then what? Then from here, we can jump forward that much. So starting from here, we start to compare again. Or if it's too small, right, and then this thing doesn't match, then we just starting from this thing, matching the start, because let's say it's not big enough, so we match the start. So we go match, doesn't match, so we go here, match, doesn't match, match, and doesn't match, and once doesn't match, wait, but if we do it this way, hold on. If we do it this way, look, so the ideal is we will have the full match, right? And then we're starting from the second spot, and then we try to match. If it doesn't match, then we just keep moving on. Doesn't match, doesn't match. And once we start matching, right, then we will match, 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 and match, and boom, doesn't match. So among these matched items, what happens? Well, if these matched items has consecutives from the start, then we'll have to go through something, right? But if they don't have consecutive starts, then it will not match. Well, let me think again. If they don't have consecutive starts, right? If they have consecutive starts, we have consecutive starts. Otherwise, then we shall go from here. So the first time we start matching, moving forward, however many times we already did, right? And so we start matching with this one, right? If it's too small, then we just match this one. So we do go back, right? We do go back. Okay. So what if it's consecutive? Because if it's consecutive, there are more, right? So we match. So we match, right? Towards the end, and we match all of them. Then we simply do the entire thing, right? Simply do the entire thing. Hold on, so we match, right? So we match. Everybody match, right? Everybody match. So all the match, and then we need to find out how much is the consecutive. Right? We find out how much is the consecutive, and we can do that, and then the consecutive counts as one, right? Yeah, let's say we keep going, and then we start from this, start consecutive again. So once we finish the consecutive part, and then we start the mismatch, and then we just from the consecutive moving forward that many times. It might work. Tempting. I'm gonna try. Not confident in this idea. We should surely try this. So what we say is rest will be len s. That's the first one, right? And then how do we know if someone's consecutive? We can count how many is consecutive in the start. Okay. Let's say we count how many is consecutive from the start. So we have the value. That will be the maximum, right? The maximum consecutive at the start. And then starting from the second position, right? Starting from the second position. And then we're going to start comparing. And then if it's not the same, then we move forward, right? If it is the same, then we try to see how long the current match is, right? We're trying to see how long the current match is. Yeah, if it's smaller than this, then this will be the one. Okay. Yeah, I think I have a good rule if there's. What if we have consecutives? We have consecutives, we have some consecutives, right? And then if we have consecutive, so the number of consecutives at the start, then we'll exhaust those, we start comparing. So we know this, right? And this will be the first one. It's a real mismatch. So I have a mismatch. Yeah, like the mismatch. How many mismatch do we have? And then we simply say if miss, boom, and we have a first match. Or we have a match again. Or like, yeah, we have like these mismatch, and then we have a match again. Then the match will be consecutive, or including something that's not consecutive. And then how do we move forward? Well, it's smaller, like, right, it's smaller than we simply just move forward by checking this. Hold on. That's like ABA. It's complicated. I feel like I'm not on the right track. Let's see hints. Yeah, that's KNP. All right. Basically, I was trying to think of KNP by myself. Oh, is it called KNP algorithm? Yeah. Knuth Morris Pratt. It is KNP. All right. Let's see if you understand. Pattern. Yeah, we have pattern. So given a text and a pattern, write a function to search the pattern in the text. And we use KNP to do this. Okay, so find it at 10. All right, the pattern search. KNP. Whenever we detect a mismatch after some matches, we already know some of the characters in the text of the text window. Yes, we can take advantage of this to avoid matching the character that we know will anyway match. Let us consider the following example. We compare the first window of the text with the pattern, and they all match. In the next, let me make this one larger. In the next step, we compare next window of text with pattern. Is working this optimizing our naive. In this second window, we only compare the fourth A of pattern with fourth character of current window of the text to decide the current window matches or not, since we know the first 3 characters will always match. We skip matching the first 3 letters. Now we do have the pre-process. How many characters to be skipped? We pre-process the pattern and construct an auxiliary LPS of size m, the same size of the pattern, which is used to skip characters. Name LPS in the longest proper prefix, which is also suffix. A proper prefix is prefix with whole string not allowed. For example, prefix ABC are this A, AB, ABC. Proper prefixes A and AB and an empty. Suffix suffix allow ABC. Okay, we search for LPS in subpatterns. More clearly, we focus on substrings of patterns that are either prefix or suffix. For each subpattern where I equals 0, LPS I stores the length of the maximum matching proper prefix, which is also a suffix of the subpattern 0 to I. So LPS I is the longest proper prefix from 0 to I, which is also a suffix of 0 to I. Hold on, let me think again. Was this the longest proper prefix? Okay, so given 0 to I, the longest this, that is also the suffix. Okay. That is also the suffix. That's exactly what it's looking for, what this problem is looking for. At each position, right? I mean, we're saying this, but in fact we want prefix and prefix. But that's fine, that prefix is just ending at that position. Alright, so at each position ending, we have the prefix matching with this prefix. So we know from here to the end. Oh, that's actually it's slightly different, right? It's slightly different. Let me think. Because we want the maximum prefix matching the maximum prefix. All right. Oh, we'll think about that later. Maybe we need to think about it right now. We want a prefix to matching prefix. Okay, longest prefix. So this is towards the end, which means this LPS is going to go from front. Like if we go from this to this, then we get it. And if it goes this to this, the longest matching will be 0. Right? These will be 0, right? And then just from here to here is to give the entire thing. But they're a matching suffix. They're matching this. Yeah, it just keep moving, it just grows, right? It grows bigger, 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 which means it's from this to the end. No, hold on. From this towards the end. Maybe, hold on. let's try this. Let's do this first. The longest prefix, which is also proper suffix. Okay, so for example, construction, this pattern is 0, 1, because at this position, the longest is this. These are all zeros. Yeah, because at each position, the longest prefix is a proper prefix, is a suffix. No, none of this, right? And for this one, we can actually walk here. We always start with 0, right? And in this position, so the longest that's equal to this, that's 1. And we're here, right? And the longest prefix is A or AA, and this is B or AB. But here, the longest will be 1, right? I can do A and A, and this will be 2. That will be 0. That's 1, 2, 3. I have AAB, AAB, and AABA. I think I'll just read the code. Compute the LPS. How do we compute the LPS? Length of the previous longest prefix. Okay. Yeah, that's always 0. I equals 1. So we look. So if this pattern I will equal to, hold on, the length of the previous longest prefix suffix. So if pattern I, so the current one, is equal to pattern length, hold on, if pattern I, so we are assuming that everything starts, so like if we have prefix, right, and then we assume that currently it's all matching, right? That's just length is the previous, right? Previous longest. Okay, so we have the previous longest matched. Now we look at the new one and the previous length. If they're equal, they'll increment. That's correct. That's correct. So if it's equal, then we increment. If equal, then we increment. If they are not equal, so the current one and the previous and the length, right? It's not equal. If it's not equal, if length is not equal to 0, so I have a length. So the previous, I have a length, right? I have a length. Then length equals LSP, length minus 1. LSP length minus 1. So LSP, so length is this. So hold on. What is length? Length is the previous size, right? So previous size. And what we find is the pattern on the length, right? Pattern on the length. Pattern on the length is not equal to pattern I. So these two are not the same. So we say if length is not equal to 0, and the length will equal to LPS, length minus 1. I don't understand. Hold on. So it's all 0, right? Hold on. I can't wrap my head around this thing. So we have these matching, and then the next one, and we find out that it's not matching. So this one and this is not matching. And if it's not matching, then it will be 0, right? No matter what, it will be 0. No matter what, it will be 0. But we want to find out the previous longest suffix. And I does not increment. Oh, we're walking backwards. Hold on. So the current one doesn't match, right? The current one doesn't match. So I need to revert to my. Hold on. So the current one doesn't match. What does that mean? The current one doesn't match. The current one we're looking at I, right? We want to know up into I. So what's the length, right? So I is here, right? And then and I have the prefix length, right? The prefix length is this. So we say, no, we cannot do the current length. I want to do length minus 1. So we find from the start to this, right? So from start to len minus 1. So from start to len minus 1. In this case, what is the longest prefix that's equal to suffix? So we find that, right? And then I do, because length is smaller, so we do pat I equals pat length. Okay, if it's still no good, right? If it's still no good and the length is not equal to 0, then we find this position. So what is this? Which is this? What is the longest, right? Length. And then we try to do again. And if it's still no good, like length becomes 0, so we don't have any, then we just set it to 0. And I know what this is. Okay. Ooh. Every single time KMP just give me this, this feeling like, wow, how did people even figure out this way? All right, so we can find out the LPS. Okay, we can find out the LPS. So how does it work? Does it work if we do LPS on the current array? So on the current array, what we know is just from a start to a certain position, right? For my problem, when knowing LPS, is like from start to a certain position, how much the front is equal to the end. That's what I know. Like this position, what's the length is equal to this, right? What's the length equal to this? But that's from left to right, right? That's from left to right. How much on the left is equal to on the right at each position? Okay, so how do we translate that into my problem? So my problem want to know from a certain position towards the end, right? Towards the end, and I want to find a prefix, the longest prefix. So if I know at the end, right, the prefix and the suffix, that's what I know, but it doesn't really make any sense because that's a suffix, right? But what I do know is the longest will be here, right? Which means, because that's the longest. If I put something here, that will be the, that will be the result, the score, right? And if we go here, then we have, this will be the longest, right? This will be the longest. But that's not considered the end. What if we go from here? I know these are the same. Hold on. What I know is at a certain spot, prefix equals the suffix, right? That's what I know. Now what I can do is start from here. We can start from here. That's the longest I can extend, right? So I can start from here, and then I know I have this, but the remainder, so I need to compare, right? This, is that equal? Is that equal? So if I have a certain spot, I have the longest, right? And then I can actually calculate every single one, right? If I have this much, so I have here. Now hold on, I cannot. Right? Like at this position, I say I have this much. At this position, I have this much. So at each position, I know how much I have. Oh, man. What do I want to create? I want to know from this position towards the end, how many are the same? Okay. So let's follow this algorithm. Let's say we know at a certain position towards the end, I know this much, and I'm going to the front, right? Let's say I have k, right? I know k is good. So like this will equal to this, I know. So I move one forward here. That's the problem. It doesn't help. Like I cannot extend. But I know from this towards the end, I have this much, and I know from this towards the end, I have this much. But what I don't know is, because I'm adding 1, right? And what I want to know is this part. Let's say at each position I know from this towards the end, how much is this? Nah, come on. So that will be the longest, right? That will be the longest. So if I put something here, I'll have this part equal to this part. So I know. And if I put something in the front, that will be something smaller, right? So So the longest, which means from this right towards the end, it's going to score this. How about from this towards the end? Well, from this towards the end, we have this and this, right? I'm still struggling, still trying to think. So at a given position, right? At a given position, what I want to know is the largest. I can say prefix, it cannot extend beyond this. So each position extend beyond, then it's no good. So the first one, right? But if the largest one doesn't hit this one, it's still no good. Oh, Lord. What am I looking for? I'm looking for this position plus the distance. And at that spot, it happens to be the same. Yeah, that's what we're looking for. So we keep searching. We keep moving forward. We +1 to see if it's equal to this, if it's equal, +2, +3, until we hit a point where it doesn't work anymore. So we know that is the longest. Okay. Okay, so we have this. Now we move forward, and we do this again. We try to match. Doesn't feel right to me. Doesn't feel right. Let me think again. About a certain position. Okay, in this position, this. What can we say about this? What we can say is at a certain thing will have a score of this. That's what we can say, right? And if this, we have something smaller. We say at a certain position, I have a score like this. But then we're duplicating, we're double counting. Oh, but we know which position it is, right? We know this position. We might be onto something now. So we create this LSP, right? And then we just move one by one. And at each position, I know how many prefix, right? So we can go to that position to say the current score is this. So you keep going on. So at each position, I will update the score, right? Update the score, and eventually add them up. This might work. So we need to first build the LSP, okay? Oh, damn. We have to actually build the entire LSP. That doesn't seem to be easy. All right, let's see if I can do this without reading. Okay, so building LCP. All right, how do we build? We have the pre-len, okay, and I is equal 1, while I is smaller than n. All right, while I is smaller than n, what do? We simply I smaller than n, we simply check, right? We say if s pre-len, which basically check the next one, right? If this is equal to si, if they're the same, right, that just means the prefix gets extended, right? And then we just say, right, it gets extended. We say pre-len plus equal 1, LSP I equals pre-length, and I plus equal 1. Right, we just keep moving forward. Else, if pre-length, my god, is not equal to SI, okay? Pre-length is not equal to SI. So this doesn't match. So we need to find out in the actual length, right? Right, in this. So in the previous prefix, what is, right? What is the LSP for that? So we can find out the LSP for that, right? Yeah, when you reduce the length, so say pre-length need to be reduced to LSP, pre-length minus 1. So when you reduce the pre-length, and then we need to go up again, until right, we just say aleph pre-length is not equal to 0, then we basically just update the pre-length, and then we try it again. Else, if it's equal to 0, right, so that if the pre-length is equal to 0, that means we don't have any pre-length anymore. Then we simply say lsp0 I equal to 0, and I plus equal 1. Right? Okay, let's check if it's the same. So lamb blah, if it's not equal to 0, this equal to this, ls. Yeah, so that is building the LSP. So once we build the LSP, I want a DP table. Okay, so that's a DP table. So now what do we do? So I will loop through the LSP. Okay, I'll loop through the LSP, and for each one, I'm trying to count. Right, and just say for the first one will all be 0. So we just say for I again in range. Say from 1 to n, right? We're gonna cover the entire thing, and we say, and this is what we say. We say LSPI is a total number, right? So then what we can do is I minus this number, right? Let's say if I in this, right? And then we say I have 3. So minus 1, minus 2. So if I have 3 elements at the end, okay, and then this is my I. We get to I, we have 3 length, which means minus 1, minus 2. So I minus this plus 1, right? Minus 3 plus 1. So at that position, we say dp that position shall equal to maximum dp that position, right? That position and the current count, which is LSPI, right? So dp at that position, the maximum we get is this much, right? Is the LSPI, the current, and then we just constantly update it, and then we keep going this until we're done, and then we're gonna return the sum of dp plus n, because we never do n. Do we do n? No, we never do n, so we have to do n at the end. Oh my god, let's see if this one works. So we have this 9. This should be 14. No other. S. Almost. Why does this one not work? I mean, we can. No, I can do. What's DPI? Oh, DPI is the what is DPI? Exactly, what is DPI? It doesn't really matter what DPI is. DPI, well, is the score from I towards the end, right? So we can actually say, because dp0, right, will equal to n. No, because from the start, right, and now it's in dpi. DP1, right? From DP1. So from 1 towards the end. From 1 towards the end, we say at LSPI, so LSP1 is the total number, right? That's equal. So if we have 1, so this position, if we say, okay, 1 is the same, then maybe I minus 1 plus 1 will stay at the same position. Hey, hold on. Yeah, we do stay at the same position. So we say this towards the end, we have 1, right? Because 1 is the same. All right, hold on. Let's take a look at the LPS. LSP. So we do BA, right? That's 0, and then this is 0, and this maximum is 1, this maximum is 2, this BAB maximum is 3. Okay. So at this position, 1, 2, 3, 4, 5, we have 5. Right? And this position from this towards the end. Well, this towards the end, LSP is 0, right? And if we do, how about LSP must be larger than 1? Let's say if LSP I is larger than 0, because if at a certain position, right? If at a certain position, and I have nothing matching, and that's, we shouldn't consider it. Still not right, but that's fine. So because from this towards the end is nothing, so we don't do anything, okay? And then so it was still 0, right? And this one is 0, and then this one we have 1, which means we have 1 and this 1. So what I say is I minus 1 plus 1, so stay here. So we just say from this position to the end, we have at least 1, right? At least 1. Score is 1, so we have score 1 here. And then we come to this position, right? This position is 2, right? LSP is 2. So I minus 2 plus 1 minus 1. So from this position towards the end, we have 2, all right? Which makes sense. So this one becomes 2. And now at the end, I have this, right? And if we are at this, it's 3. So minus 3 plus 1. So this actually becomes 3. Then we're done. So we are missing. We're missing the last one. Because this one tells us 3, but the last one is also the same. So like this position is not updated. And how do I update this position? Well, to update this position, I need to know how much is from this towards the end. Because remember, now what we're calculating is the total number of prefix that's matching. But when we go to the end, Still no idea. Oh, so at this position, say BA equal to BA, right? I need another hint. No, this is not working. What's the second hint? What the hell is a Z array? What the hell is a Z algorithm? The LSP doesn't work on this. And I can't figure out if to write another one that can help. Alright, this is taking a bit too long. I still don't want to give up. So let's just stop right now and then keep thinking. If I can, keep thinking. I'll come back to this tomorrow. If I can't figure anything out during the day, tomorrow we'll look at a solution. Look at how other people solve it. So currently, even with KMP, I still have no clue. Like this, and it's just still not working. Still not working. And what the hell is this Z algorithm? Like, seriously, what is Z algorithm? Could you use a Z algorithm? I'm just curious. What is Z algorithm? Oh my god, this is actually, it is an algorithm. Linear time pattern searching. Okay. All right. Z array. So yeah, KMP doesn't work, so we have to use something called Z. All right.